Hello and welcome to this quick introduction to machine learning with Python. In today's video, we take on the role of an employee of Capital Bike Share, a bike sharing system in Washington, D.C. And our task will be to predict future demand for bike rentals. In order to do this, we've been provided with three, you could say, Excel files. I already opened up the first one, the so-called training dataset, and we are looking at the first 10 rows of it. We are seeing 10 columns here. The first one being the date time in 1 hour steps, the season 1 being winter and 4 being autumn, the holiday 0 meaning not a holiday, 1 meaning a holiday, working day just like holiday, the weather situation 1 being good weather, 4 being like blizzard, the temperature most likely in Fahrenheit, the parent temperature, the humidity in percent, the wind speed, most likely in miles per hour, and then, last but not least, a column named count. In this column, there's the information of how many bikes have been rented out at this point in time. For example, on the 1st of January in 2011 at midnight, we have rented out 16 bikes. This is the so-called label or target. It's information we will try to predict. Also, we've been given a second dataset called test dataset. These are the first 10 rows of this dataset, and we see all the columns from the training dataset except for the count. And this is for a reason. In order to check the quality of our predictions, the company did not give us all the labels it has in its data pool. It removed the labels on some of its data in this so-called test set. So now it's our job to do predictions on this so-called test data. Then we can deliver our predictions to the company, and the company can use our predictions on the test data set to check whether we have a good prediction system or a bad prediction system. Then last, we have one more file. The so-called prediction file is just like a form with which we can submit our predictions to the company. We have the date time, and then in the count column we can predict the amount of bikes used at this point in time. That's the same dates as in the test data set, as you can see. As I already mentioned, the company needs to test the quality of our predictions. In order to do this, it needs some sort of metric. We will use, in this video, the mean absolute error, and I put a little bit an example table on the screen right here. We have a true value and a prediction, and we have an error here. We say that the error is the true value minus the prediction. For example, in this case, 10 minus 5 is 5. Or 10 minus 15 is minus 5. Or 25 minus 5 is 20. So these are the errors. For all these errors, we can take the absolute value of this error. For example, for the 5, it's 5. For minus 5, it's 5. And for 20, it's 20. And then we take the mean value of those, like for example 5 plus 5 plus 20 is 30, and since we have 3 observations, the mean value of those is 10. That's what we see here again. We see that we have a sum of absolute errors of 30, a number of observations that is 3, and the mean absolute error being 10. Now that we have established this mean absolute error, I'm having a little bit of a function to score our predictions later on, because in this case I'm not only the employee for some reason, but also the employer, checking on our own predictions later on. So this is what this function is for. I have the solution somewhere in a CSV file as well, and then I'm using this mean absolute error function from some Python package and put in the solution and what we predicted, and then it returns the scoring of this. For example, I can use this mean absolute error function on the true value and the prediction of my example, and we get 10 once again. Now, one big question is, what is a good mean absolute error? Is 10 a good mean absolute error? Is 1 a good mean absolute error? Is 0.001 a good absolute error? Or is 1 billion a good mean absolute error? The answer to this question is, it depends, as always. Everything is relative. So we need to have some sort of relative benchmark. For example, something very stupid that we could do be predict 0 for every point in time. I do this right here. I write into the column count in the predict table the value 0, and then I put this prediction of count into my scoring function. And now I can see that in this case I would have a mean absolute error of 186. But since this is very stupid, we move on directly to another baseline model. In this case, what you would usually do you would just take the training data, all the labels from the training data, and then you take the mean of these and predict it for all the test data. This is what I'm doing right here, and then I'm scoring this again, and we already dropped our mean absolute error from 186 on this very stupid prediction to now 143. And now this will be the baseline from which we are trying to improve. The first thing I'm doing here is I'm doing some what we would call feature engineering in machine learning or data science. I'm constructing some new columns that we will see right here. Once again, we're looking at the first 10 rows, and we have seen here 7 new columns that I added. Most of these columns, or to be precise, all of these columns are based on date time. Currently in this format right here, this is like a string, and the computer cannot really use this form of data. So I'm extracting the information out of this string, you could say. For example, I extracted the hour. In this point it's 0, and at this point it's 9. I expected the day, that's the day of the month, that's the first day of the month, the day of week. In this case, this is a Saturday, so it's 5, a Monday would be 0 in this case. This is the 52nd week, so it's still counting towards the year 2010. It's the first month, it's the year 2011, and it's a weekend, obviously, because it's a Saturday. Now I'm doing a little bit of a plot. On the x-axis right here, we see the hour of day between 0 and 23. And on the y-axis, we see the amount of bikes that have been rented out at this point in time. Now we have 2 lines, a red line and a blue line. The red line shows the average amount of bikes being rented out on weekdays at this hour of the day. For example, in this case, at 8 AM, we had an average of around 470 bikes rented out on a weekday, while on weekends there was only around 100 bikes rented out. On the other hand, around noon, when everybody's working on a weekday, the weekends are much stronger. We have around 400 bikes rented out from the time of like noon until the early afternoon. And then we can see again on the weekdays that in the afternoon the people go back home, so we have another spike here at around 5 PM or 6 PM. So that's also around 500 bikes rented out at this time. Now I will try to use this information for a better prediction. I'm doing some technical stuff here, and then I'm using all those averages for weekend, yes, no, and the hour of the day to make a better prediction. We have the test data set here again, and now I'm using the hour and the weekend to predict a count in this count column. For example, at midnight on weekdays, on average in the training data, we had 38 bikes rented out. At 4 AM on weekdays, we had an average of around 5.5 bikes rented out. So this is now what I'm predicting. For every time slot in the test data set, I'm looking at its hour and information if it's a weekend, yes or no. And then I'm looking up the mean for this hour and this weekend, yes, no, in the training data set, and that's my prediction. Now I'm writing this into my prediction data set again, and I'm scoring it. And now we're dropping down to 77. Previously, as you might remember, we had an error of 143, now we're down to 77. Now finally we can come to what you would usually consider the real machine learning. We are training some arbitrary machine learning algorithm which is able to find some sort of a function that maps our data to a label. In this case, I'm using the light gradient boosting machine. To keep it simple, I say this is a huge amount of decision trees. In this case, we can be precise, I'm doing 500 of those decision trees. And I'm just telling him, take all the data and try to find a way to build a function that functions this training data to the training label. And then I can use the algorithm, the model that it produced, to predict my outcomes on the test data. So that's what I'm doing right here. I'm training this now, And we are done. Now I'm doing the prediction right here. I'm using my model that I built right here to predict it. And then I'm writing this into my prediction count column again. And then I can use this to score my prediction that is now based on what you would call real machine learning. And now we're down to an error of 31. So we dropped from 143 on our first not so unbelievably stupid prediction to then 77. And now finally we got down to 31. And that's not the end of the line. There's still a lot for us to do, but that's for another video maybe. So see you around.